All right, before we start this lesson, we're actually going to go to notes. And I'm going to make up a problem before we do theirs, because theirs, Pearson kind of begins a little confusingly. Is confusingly a word?
Yeah, a little, I guess.
Is it? Okay, we're going with it. Thank you. We will.
Wait, Michelle, can I have a question?
What?
About your midterm, how many questions are there?
I can't answer that quite yet. I don't have it all done. So I will let you know within the review period though. What's up? Okay, so first example, example number 1. This is what your problems are going to look like. Let's say 2x plus 3 plus 5x plus 4. Okay, copy that down as problem number 1.
In all problems like that, you always have to find the GCF.
No, we're actually doing something different today.
Oh, no, let me guess.
What do you want to guess?
So we add 2x plus 5x.
Yep.
And add 4 plus 3.
Yep.
That's our answer.
Exactly right.
Ah!
Okay, so somebody tell me, Ivan was completely right. He said we're gonna add 2x and 5x, and we're gonna add 3 and 4, and that's gonna be our answer. First of all, why would we add 2x and 5x in particular? Donnie? They're like terms. Yes, they're like terms because they both have x's. Why would I add 3 and 4? Claire?
Gosh, they're done.
Sure. There's not much to answer on this one, but okay.
They don't have like terms, but like the same variable. X.
Okay,
They don't
right,
have
so they're
X.
different from the x's.
Mhm.
Right. Okay, Claire, since you're standing, hold on. Stand back up. Why would that then be my answer?
Because
Like, why would I get my x's added and my numbers added and then not do any more?
there's nothing else.
Why?
Because those are the only numbers.
William? Stand, you're not done yet.
Because, because they're not like terms. The final products are not like terms because the regular numbers do not contain the
Right.
X.
When I add these, they're gonna have x's. When I add these, they're not gonna have x's, which means in the end, I can't add those two together then. They're not like terms. Okay, have a seat. So before we just jump into adding these together, I want you to recognize a few things. First, the use of the commutative property. Do y'all remember what the commutative property is? Mateo?
So 4 plus 3 was equal to 4, basically.
Okay, so you can move around the order of things. So if I want to add 2x and 5x, I can actually rearrange this so that the 2x and the 5x are next to each other. And then I want to add the 3 and the 4, so I can rearrange those and put those next to each other as well. Okay, so I'm just taking them out of those parentheses and then rearranging them in the way I want them. I can then use the associative property to regroup what I do want to add together. We've done this before. Do you recognize this?
Yeah.
Yeah? What?
Would this not work if like there was subtraction?
Right, that's going to be tomorrow.
Subtraction.
That's going to be tomorrow.
It's gonna be the same thing, but just subtracting.
Right.
Oh, okay.
So we're going to add these two together and I would get 7x plus 7.
Oh,
And now the part that I was asking Claire, why we have to be done at this point, and the answer is because 7x and 7 are not like terms. All I have is this expression as an answer. I can't do any more than this. So that is my answer. Okay? Now, some trouble is some of these are going to have decimals and fractions in them as well.
Oh.
So you have to remember your decimals and your fractions and do all the work there. Evelyn, is it working?
Yeah.
Okay.
Just moving.
Okay, everybody got this one written down?
Making 10 in the way?
Okay, number 2. Let's do, copy it down as I'm coming up with it, okay? Okay? Don't panic when you see these fractions. Yes, you will have to deal with them. But first deal with the act of just figuring out what you need to add together. Rearrange what you need to rearrange. And then think about the fractions. So don't even worry about those yet. We just need to get this rearranged. So what order can I put this in so that my like terms are together? Ivan?
So 1/2 x
Good.
plus 1/3 x
Yep.
plus 3,
Yep.
no, 1/3. Or no, 3/1
3/1 we could do, sure.
plus 1/4.
Why did he make that 3/1? We don't have to do that, but why might you choose to put 3/1? Sam? Right, because I have to add that with a fraction. So if everything is a fraction, it might be a good idea to keep a whole number, put that into a fraction. Okay, thank you, have a seat. Good. Yes, yes, yes. Okay, we're gonna group those and those. We want the x's to be added and I want the numbers to be added. For this group, what do I have to do? It's not quite as straightforward as my last problem because now I've got fractions, so I can't just add these together and get my answer. Eliana? Have to get a common denominator. Was it? 6. It's 6. Okay? What's 1/2 gonna be with 6 in the denominator? William?
3/6.
3/6. If I want to get that as a 6, I gotta multiply 3 and 3. If I want to get that as a 6, what do I have to multiply by, Jude? 2. Okay, so what do I get?
2/6.
2/6x. Okay, since you're up, Jude. What?
Add them.
I can add them, yes, but I'm gonna worry about this next. Do I have to get common denominators to add the second two here together?
Yes.
Yes.
Yes, you do.
No.
The way I have it written right now, I do.
No, but you can do butterfly.
Well, I mean, I could get common denominators, but if I have 3 and I add a 4th to it, you should know what that answer is. 3 plus a 4th is 3 and a 4th. You don't actually need to do the work to add those together.
So that
Simple
answers the
fraction.
So I'm gonna change that to just 3. 3 plus a 4th is 3 and a 4th. So if you didn't recognize that, it is gonna take you longer because you gotta get your common denominators and add them together and all that. But you'd still get 3 and 1/4. Okay, have a seat, Jude. I thought I had another question, but I don't think so. Okay, so the numbers are done. Now I gotta worry about the x's. What's 3/6 plus 2/6? Jace.
4/6.
5/6. And don't forget the x on that because it changes your term if you lose the x. So it's 5/6 x plus 3 and 1/4. Can I do anything else?
Nope.
That's it.
What?
Yeah, Mateo?
So for the second one, 3 plus 1/4 add them together.
Yep.
So how can you like put out? Oh, never mind. Because that one's a whole.
Yes.
So that one's not.
Right, yeah. Okay. I'm gonna go back to Pearson now. And watch the first video. Now that you have a general idea of what's going on. Evelyn, has something going on with it? No, you just keep looking at it.
Yeah.
Okay, everybody ready? Ivan?
Yes.
Okay.
How can properties of operations be used to add linear expressions? Think about this question during the lesson. Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after M months?
Okay. I'll make this a little bit bigger. Tell me what's going on. have somebody that signed up for rock climbing and a health club. Tell me about the rock climbing. What kind of cost does she have for rock climbing? Claire?
How much, like, altogether?
No, not all together. Just tell me what's happening.
The initial fee is $65 and the monthly fee is $40.
Okay, what's an initial fee? What does that mean?
One you pay every time.
No.
Yearly.
It's money you pay at the beginning once, that's it. So initial fee means a beginning fee of $65. So all you pay is $65 one time when you join. What do you keep paying? $40 every month. So this is the one you have to keep paying. This is once, this one you have to pay every month you're going. What about the health club? Describe that scenario. Evelyn?
The initial fee is $80 and the monthly fee is $50.
Okay, so how many times do I pay? 80?
You whenever you first join,
Once, good.
and then you pay $50 every month.
50 every month. Okay, so it's important that you see which one you do multiple times, because which one does your variable go with? The one you do once or the one you do multiple times? Hannah? The one you do multiple times. Good. So I want you to write these two things down in your notes. Video? Can you copy this information in your notes, please? So put rock climbing, and then put these two values.
Giving that one, the A's Health Club?
Yeah, and then do the health club and put its two values.
Why is the health club more expensive?
Should taking care of you.
Maybe it's like personal fitness or something.
Oh,
Like a
Yeah,
personal
like
trainer
a-
perhaps?
Oh.
Like a health club is like
I don't know. Rock climbing is more expensive than that. I think.
In Rock Springs, Wyoming, it's like a really small town, and like they have this one like rec center, and like they have this really big rock wall that's like 100 feet or something like that. And so it's like $20 for like 2 hours.
Oh,
They don't charge a lot for it.
got it, yeah. Okay, do some of you have this written down? If you don't, that's okay, because I'm gonna write it in the notes too. But I need somebody that has it.
I do.
I have this.
Okay. So number 3. We have rock climbing. Rock climbing was
$65 initial and $40 the monthly.
good. Okay. And health club.
$80.
80 initial?
Yeah.
Okay. Okay, make sure your numbers are right. Are we good? Okay, and we are trying to write the total she's going to be paying. What does the word total mean? Donnie?
The total means altogether.
Altogether, what math operation?
Addition.
Addition, good. Like it's the total bill at the grocery store, it's your total bill at a restaurant. It's all the things added together. So we need to figure out an expression for rock climbing and add it to the expression for the health club. We need the total or the sum of all of this. Donnie, go ahead and have a seat.
Okay.
So underneath rock climbing, I've got to figure out how to write this information in math terms. So how many times do I pay 65?
Initial.
Once. And, so, and, plus, and I pay $40 monthly. Eliana?
40M.
40M. Okay, that's our rock climbing cost. Plus, then I need to write an expression for the health club. How am I gonna write the expression for the health club? What's that gonna look like? Sam? 80 plus 50M. Where do you decide to put the variable? We talked about it once already, but where do we put the variable? Because I've got two numbers. How do I know that 40 has a variable with it? Nathan?
Oh, because you have to keep on paying it.
Because you have to keep on paying it. Yeah, it's the one that you have to do repeatedly and forever how long you go. You don't pay your initial fee more than once though. Okay? Somebody take this and rearrange it now for us. I've got everything I need, now I just gotta figure out how to add these together. So use the commutative property and rearrange my values. Carolyn, I don't think I've heard from you yet. How would I rearrange these?
So, in parentheses, you would put 40M
Okay,
plus 50M.
Yep.
Then close the parentheses plus 65 plus 80.
very good. What? Would it be okay if I put my numbers here and then my M's here? Yeah, it's the same thing, it's just the way that Carolyn chose to. I typically put my variables in the first parenthesis and my numbers in the second, just to keep it the same, but it doesn't matter. Now, this is not fractions or decimals, so we can add these together pretty quickly. 40 plus 50, 90M, plus
145.
145. That's the expression for the total amount of money she's gonna be paying. Couple of questions you might be asked. What is the total initial fee she has to pay? Between both places, what's the total initial fee? Evelyn?
$235.
No, I know where you got that from, but it's too much.
Oh.
Eliana? 145, because her initial fee here was 65, her initial fee here was 80, so the total initial fee is those two added together, 145.
Oh.
What does the 90M represent? Ivan?
Oh, wait, no.
Oh, no? Landon?
Can I say that?
Sure.
Okay. The monthly fee.
The total monthly fee,
Yeah,
right?
yeah.
Because one is 45, one is 40, and one is 50, so total every month she's gotta pay $90. Would that be important for someone to know? Yeah, you need to know how much in all you're gonna be paying, you need to know how much money is going out. Okay,
Because if you get
have
a
a seat.
paycheck $90 on it, you're gonna be like,
All right, right,
that has to come on.
yeah.
Sophia,
So different scenario here. We're talking about Sophia and Oli.
I thought it was all.
Ollie?
Because it says O-L-L-I-E.
Maybe, Ollie, we call him Ollie.
That's what my sister was.
No one?
They name your sister Ollie?
Oh, cool.
What?
I didn't know that.
Sounds like more than.
Well, I know Oli is a boy's name.
Yeah.
I don't know about, obviously.
Some
I
are
don't know
girls'
that's
name.
commanded.
Tell me what Sophia is doing with her money. With this right here, describe to me what Sophia's money situation looks like. William,
Well, like she paid a $120 initial fee
okay,
for like, and then she's paying $150 each month.
each month,
Like
very
if
good.
she's taking a school,
Yeah.
she does 120, and then every month she has to pay
Okay, so let's talk about like a bank account. She begins with $120 in her bank account, and then she proceeds to put $150 every month into her bank account for some number of months. We don't know how many. What about Ollie? What does Ollie do with his money? Nathan?
The $120 is the initial fee, and 135 is the
Okay, so what's different between these two? What's the same and what's different? Mateo? What? The 120 is the same. So their starting points are the same. What's different? Evelyn?
Their monthly fee.
How much money they put in total, in monthly total. how would I write this expression? How would I put this into math terms? How would I put this into math terms? Eliana?
120 plus 100.
120 plus 150 M. Again, why is the 150 M, Sam? Because it's in months, it's multiple times. What would this one be? Jace?
120 plus 135.
Good. Okay, so let's write that down. This is number 4. Can you remember what it was? I know they both started at 120.
And then and 5
So this is what we're trying to do. We're trying to find Sophia plus Ollie. We're trying to find the total money that they've got. And Sophia started at $120 and added in $150 every month. Claire, you got this? And Ollie started at 120 as well. But how much, Evelyn?
135 M.
His was 135 M.
I had it all sold out.
So I want each of you to rearrange this to be able to add together your like terms and find the answer. Rearrange it, add them together. Put your hands down for a second, give people a little bit of time. Add these two together again. Just something happened when you added.
Oh, that's
And you're
2.
adding these two. Yeah, Evelyn.
Yes.
It's online. It was online. It was? Yes, it was. Well, yeah, he was asking about yesterday. Oh, yeah.
I go to the restroom. Oh, Jay sits by himself.
Oh, Bailey's sick.
Oh, yeah. She has to pee.
Okay, rearrange, this is what you should have. Yes,
Yes.
I had a few arithmetic errors out there. What's 150 plus 135? Evelyn?
285.
285, yes.
I was doing like multiplication and addition at first, you know.
So 285M plus 240. So total, what does this mean? Between Sophia and Ollie, what does this mean? William?
That's how much money they deposit. They deposit total.
Good, they deposit this much money every month total. What does this mean? Carolyn?
How much money they both originally had in their bank account.
Good, originally had together, yes. All right, how are we doing?
Good.
Okay. Okay.
Way too short to touch touch that.
No, I can't touch them.
Will we have time to work on my
I feel like maybe we will.
Okay. I want to finish that thing.
You got 18.
I'll still get a 75 in 100.
What do you mean that? Then who gave it to you?
Why went down
Choo. Naughty boy.
Okay,
Did you do Samsung?
let's go to this. I feel like this is where our practice is gonna need to be, right?
Oh.
You guys write this down?
No, I
I
don't
showed
think it's.
Rich.
Write it down. Don't complain, just get to work.
Oh, wait, Michelle, can I say my idea how this works?
How about you write it first? And then I will take your idea.
Wait, you just want us to solve this?
No, I just want you to write it.
Oh.
Brayden, I need you to write this down.
Are those negatives or some negatives, right?
Well, this is a half x minus 3 minus
Oh,
2y.
those are negative.
Those are
3.
subtractions.
Okay. But then they want us to add it too.
Wait, this is
Write it down. I'll walk you through this one.
Can I say my idea?
Okay, 2, what is your idea?
I will take 1/2 x plus that,
Plus what?
a half, 1/2 x plus 1/4 x,
Okay?
and then you get that answer,
Okay.
or whatever it is, and you put that down,
Yep.
and you put a little minus sign, and you do 3 plus 5, because those have no variables,
Okay.
so that would be 8. And then,
Except this is negative 3,
oh, that's
right? Because there's a
negative 3.
minus there.
Oh,
So
it'd
we'll do
be-
that in a second, but yeah, those two numbers go together.
And then 2y, or negative 2y plus another negative 2y.
Good. So we actually have 3 sets of like terms in this problem. We have x-like terms, number-like terms, and y-like terms. So when we rearrange this, how many sets of parentheses will I have?
Too many to count.
Not too many to count, 3.
3.
We're gonna have an x parenthesis, a number parenthesis, and a y parenthesis. Be careful though, you have it written down, can you, I'm gonna need somebody to.
We got it.
Are we gonna subtract the?
No, it's 1/2 x. It's 1/2
Oh,
x.
yeah. The second one was 4.
Yeah.
1/2 x.
I don't know if we do
1/4 x.
1/2
Negative 2y.
It's one, you don't need 1/2
Negative 2y plus 5.
Okay, so with this problem, whoa, I'm going to rearrange it to put the like terms together, but you have to be really careful with what's a minus and what's a plus. So I'm gonna put 1/2 x first. Mateo, can you shut the door? 1/2 x is gonna be combined with 1/4 x. So 1/2 x plus 1/4 x go together. Plus, and it's always plus because I'm adding these together. So in between the parentheses are always gonna be plus signs. The second set of parentheses, let's put our numbers in the second set of parentheses. What is this one?
Negative 3.
Negative 3 plus
5.
5. So that's a negative 3, that's a plus 5. So you copy them down with whatever sign they have in front of them. Plus, because that's what I'm doing is adding these two expressions together. Plus, this has a minus in front of it, so I'm going to bring down a negative 2y
plus another
and
negative
another negative 2y. So each of these sets of parentheses have kind of a different issue. The first parenthesis has an issue of I have to add 2 fractions together. The second parenthesis has the fact that I've got a negative and a positive, so I need to remember how to do that.
Isn't
The
it
third set of
negative?
parentheses, they both have negatives, so I need to remember how to do that. So it's kind of all the things you've been learning this entire semester put into one problem. A little bit. For this, what do I need? Just do one set of parentheses at a time. So with fractions, what do I need? Jace? What do I need in order to add these fractions together? I need the same denominator. Very good. So what's going to be the denominator between 2 and 4? 4. So this needs to be multiplied by 2 to get 4 in the denominator. So I'm going to have 2/4 x plus 1/4 x. I can't add those until I've done that. So that's my step right here. The next step I'll be able to add them together. These two. Do I add or subtract when the signs are different? Evelyn?
You subtract.
You subtract them. So 5 minus 3 is
2.
2.
And
And the bigger number is positive, so it's a positive 2. Plus, so that one's actually all done. The numbers are done. With the y's, do I add or subtract the numbers together when they're both negatives? Ivan?
Subtract.
no, you
You
add.
Oh, no, add them.
You add them when they're the same. So 2 plus 2 is,
4.
Negative.
so negative 4y. So the last 2 sets of parentheses are all done. It's just this first one I have work. Jace?
How do you get the 2 above the 4 in the first one?
Oh, on this one? In order to get this 2 to be a 4, you had said the denominator needed to be 4. I have to multiply it by 2. So these both need multiplied by 2.
Oh, okay.
So 1 times 2 is 2, 2 times 2 is 4. And any questions on either of these two before we go on where those came from? Why did we subtract these ones? William?
We subtracted those two because it was a negative and a positive.
A negative and positive, different signs. Why did I add these two? Mateo?
They're both negative.
They're both negatives, they're the same sign. Now with the fractions, what do I get? Add these together for me.
Oh.
Hannah, what do I get? 3/4 x.
That's a cute long time.
Ivan? Ivan? No. Do I have anything else I can do?
No.
I don't have any like terms anymore. So get everything added together that you can add, and that's it. Do these take a bit of work?
Yes.
Do they take a bit of organization?
Yes.
Yes, they do.
I do know.
So I will not go ahead and say that these are easy problems. If you don't do all this work and write all this out, you're bound to make an error somewhere. So make sure you rearrange them, put the parentheses around, do what you need to do all the way down, okay? Don't shortcut any of these steps today. Let's do A. A. Can you copy down A? We haven't done any decimals yet today, so let's review some decimals. Copy down problem A. Landon?
Can I use the restroom real quick?
Brayden, you need to write down problem A. How many sets of parentheses am I gonna have when I rearrange this? Eliana, why did, she said 3, why did you say 3?
Because we have one pair of line terms together.
Okay, so with this C here, is there anything else to C?
No.
No, so this can be alone in a set of parentheses. Plain numbers, do I have any other numbers?
Yes.
Yep, so that's gonna be with the other number. And then I have a variable P, Any other like terms?
No.
No, so that's gonna be alone in a set of parentheses. So I have 3 different kinds of terms that I have to write out.
So those are already done, correct?
What do you mean?
The 9.74 C's already
Right,
done.
yeah, because they don't have a like term, so that makes life a lot easier for us. So I'm gonna put 9.74C in a parenthesis by itself. It doesn't have a like term, so it's not grouped with anything else. Plus, what numbers are gonna be in my second set of parentheses? Be careful here. Mateo?
Is it negative 250
Yes.
plus positive 185.7?
Yep. Why is it a negative 250.50? Sam? Because there's a minus. You have to make sure you bring that down with the number. And then the negative 5.48. Sorry, that one kind of got cut off. That's, do you see what number it is though?
Yes.
Eighth graders help me come up with that. I got rid of the problem that was here by covering over it with white. It's very tricky. Okay, does this one have to be in parentheses?
No.
No, like I don't have any work I have to do. Usually we do the work and then take it out of the parentheses, but that one doesn't need any work. So I'm gonna write 9.74C. There's no work to be done. Now this one I've got work to do. I've got 2 terms in there. It is an adding problem, but do I add to find the answer to my number?
No subtract.
No, I have to subtract because I've got a negative and a positive. So I have to subtract those 2 numbers together. Bigger minus smaller. So up here, I'm going to do 250.50 minus 185.7. You will usually need some space off to the side when you've got decimals. So subtract these, 0 minus 0. You can't do 5 minus 7. Oh, and I can't borrow from a 0.
So it's an
So I'm gonna make that a 10, borrow from the 10.
and that's 8.
So 15 minus 7 is 8. 9 minus 5 is 4. Can't do 4 minus 8.
6.
So 64.8.
That's a negative.
Negative.
Evelyn?
It's a
And
negative.
it's a negative, good, because that big number was negative. Just because it's a negative, I'm gonna put it in parentheses. Yeah. You don't have to, but it does keep the plus and the negative number kind of separated. And then we have the P term that didn't have a like term. How come I took this one out of parentheses, but I left that one in parentheses? Johnny?
You do not want to get confused between the negative and the plus sign.
Right. I just kept it to keep it organized, to keep the negative kind of separated. Nathan?
Doesn't matter, right? For example, I put the a negative 5.48 feet after the second number.
Okay.
Doesn't matter.
Okay, would it matter? Good question. Nathan said, does it matter if I put the C term, the P term, and then the number? No, doesn't matter a bit. Commutative property says any order is fine. Good? Okay, your homework is online. Hold on. Does that mean you don't need to write things down?
No.
No, it does not. You will need a sheet of paper.
Give me to start. Give me to end this.
Yes, yes.